So let's practice our sets knowledge by solving one problem. So what we have here, there are 3 hairdressing saloons, S, X, and Z, located within a large suburban shopping complex. A survey is made of female shoppers within the complex to determine whether they are clients of S, X, or Z. 83 women are clients of at least one of those. 31 are clients of S, 32 are clients of X, and 49 are clients of Z. Of the women who are clients of S, 10 are also clients of X, and 14 are also clients of Z. 12 women are clients of both X and Z. How many women are clients of all 3 saloons? So the easiest way to visualize this problem is by drawing some Venn diagrams. So in this case, we will have 3 sets, X, S, and Z. All of the people that we're considering are inside of at least one of those. So if we draw our rectangle here outside, there's no one here. So there's no one outside of those 3 sets. Now the question is asking us for how many women are clients of all 3 saloons. So all 3 saloons would be the intersection of all of them. So it's here in the middle. So since this is an unknown, I don't know the value, I can just assign a value lowercase x. Okay, I could even use a different letter here just not to confuse you guys, but since there would be no another x on the calculations, just notice that anything that we're going to do here with lowercase x, it's actually our unknown and not our set. Sets are denoted by uppercase letters. So what we have to do here, we have to follow each of those pieces of information and try to get from the inner part outwards. So we're given some information regarding 2 sets at the same time. So of the women who are clients of S, 10 are also clients of X. So if we look at our sets here, at our Venn diagrams, the women who are clients of S and X at the same time, they would be this portion here, that's the intersection, right? So when I say this means S intersection with X, and we are basically saying that the number of elements in there is 10. So if this whole thing here is 10, but here in the middle we have already counted X, on this part I'll need to have 10 minus X, because I have already considered X of those. So if there's 10 in total, and let's say there's 2 here, there would be only 10 minus 2 here, there would be 8. If this is 5, it would be 5 and 5. The total has to be 10. And we can do the same thing for the other intersections as well. So we are told that women who are clients of S, 14 of them are also clients of Z. So if 14 women are clients of S and Z, this is what this means. And we could even do the next one. 12 women are clients of both X and Z. So the number of elements in the intersection X and Z would be 12. And we can fill in those other blanks by using this information just like we did before. So the intersection between S and Z is 14. There are 14 people who are in both sets at the same time. So if we look at our intersection here in our Venn diagram, S and Z it would be this portion here. So if I'm already considering X people, X women here in the middle, and it should be 14 total, this will be 14 minus X. Likewise, this other portion here, which would be the intersection between set X and Z, I would need to have a total of 12, therefore this is 12 minus X. So we can easily check that whatever X is, we will have the totals that we're told in the question. Now the next step is for us to go to our sets S, X, and Z as a whole. So we are told about the number of people in each of those sets. So we know that the number of elements in set S is 31. We are also told the number of clients, so the number of people in set X is 32. And lastly, we're told that the number of elements on set Z is 49. So the reasoning is similar now. If we look at our set S, the total of elements here in this set should be 31. However, we already have 10 minus X plus 14 minus X. So, how many would I have only in this portion here? So how many women go exclusively to saloon S? Well, if the total is 31, I need to subtract what I have in those intersections here. So I will have to subtract 10 minus X. I will have to also subtract the X, which is here in the middle, and we will have to subtract the intersection that we have here. So 14 minus X. So this is 31 minus 10 plus X minus 14 plus X. Note here that when you have a negative sign in front of your bracket, you will change all the signs inside. You're basically multiplying by -1. And if you multiply all of the terms here by -1, what you'll do in practice is just flip the signs. So I can get rid of some X here, and if I do 31 minus 10 minus 14, so 7 plus X, right? So this is what we have here, 7 plus X. Now we can do the same thing for set X and set Z to know exclusively how many of those clients are exclusively clients of set X or set Z. So this was for S. Let's do the same thing for set X. So the total number of clients on set S was 32. However, I have already counted some people here, so I'll have to subtract those. So 12 minus X, and the procedure is really the same that we have done before for the other sets, just with different values. You will have to use exactly the values that you have in here in between. And this makes sense because 32 would be the total here, but you have already taken into account those people. So if you want to find just this part here, you will have to subtract them. So if we follow this through, we'll have 32 minus 12 plus X minus 10 plus X. So we can again get rid of some X here, and what we have is 32 minus 12 minus 10 plus X. So this is simply 10 plus X. That's fair enough. And our last set, and we're getting to the end of the question, we can do the same thing, but the total now was 49. So 49 minus, and then we'll have to subtract those guys here. So 12 minus x minus 14 minus x equal to 49, and now we expand. Minus 12 plus x minus 14 plus x. So we can get rid of some x here again, and if we do 49 minus 12 minus 14, we should get 23 plus x. So now we know exactly how many elements we would have, so how many clients we would have in each saloon, right? Well, now let's go back to our question. So how many women are clients of all three saloons? So you might ask yourselves, okay, I've got loads of X's everywhere, but how am I going to calculate this? Well, you know the total. The total is given. So we know the total number of women here is 83. So we can add all of those to get 83. Now there are loads of different ways you can do this. You can add each bit here, so you can do 10 plus x, 10 minus x, 7 plus x, 14 plus x. But this is going to take quite a while. So what I suggest, and what I'm going to do here, I'll take one set, let's say set Z, and what I'll do, I'll consider, let me change the color, I will consider this set, because I want to know what X is, but I know that this set Z contains 49 clients. So if I'm working the total, 83, which is the total number of people, should be the sum of this set Z. Now this portion of our set X right, and this portion of our set S. Now again, you could just add all of those, but it would be quite cumbersome. So what I'm showing you here is that you can do this in an easier fashion. Because now what we can do here is 83 is the total. So if I add this set Z here, which is green, well, I know that set Z contains exactly 49 people, plus, now what about this blue part here, which I had left? It should be 10 plus x plus 10 minus x. That's the total number of people that we have here when we take out those two. Plus, and now the last part here, which is just the exclusive s. 7 plus x. And now we solve it. So, if we rearrange this, we would have, well, we can cross out some x's here, right? So we would have x equal to, I'll just make x my subject, and I'll have everything else on the other side. So on my right hand side now, I would have 83 minus 49 minus 10 minus 10 minus 7. I could have added those, that's fine. Just wanted to show you as many steps as I can. And the answer to this is 7. And that's your answer to the question. X equals 7. So there are 7 women which are clients to all three saloons.